Hey, 7th graders, we are going to do some NS2A practice today. We are multiplying and dividing rational numbers. Okay, so the first one we have here is two mixed numbers that we need to multiply together. And we're going to rock around the clock and first change those into improper fractions, and then we will multiply. So remember, we have to multiply first. 4 times 4 is 16. And then we add 3, which is 19. So we get 19, and the denominator stays the same over 4. Don't forget the sign, which is negative. The second one, we multiply 2 times 1, and then we add 1. 2 times 1 is 2, plus 1 is 3. So that becomes 3. The denominator stays the same. The nice thing about multiplying and dividing is that we do not need a common denominator. We can just multiply straight across right away. First thing we should look for is to see if we can reduce any fractions or do any cross canceling. Okay? So if I was going to cross cancel, I would look at 3 and 4 and determine if they have any common factors that I could divide out. Nothing goes into 4 and 3 evenly besides 1, so there's nothing I can cancel. And then I would do the same thing and look at 19 and 2 and see if there's anything I could cancel, divide out there. But nothing goes into 19 or 2 besides 1 either. So I can't reduce anything. 19 over 4 doesn't reduce because 19 is a prime number. 3 over 2 doesn't reduce because 3 is a prime number. So there's no canceling or simplifying I can do before I multiply. So then all I have left to do is multiply. So 19 times 3 is 57. 4 times 2 is 8. And a negative times a positive always becomes a negative. Negative and a positive makes a negative. Now it says I have to answer as a proper fraction, whole number, or mixed number. This is an improper fraction again because the bigger number's on top. So I have to divide to make it into a mixed number. So how many times does 8 go into 57? Well, I know 8 times 7 is 56. Subtract and I get 1. So it's 7 and 1, 8. Don't forget my negative. My final answer is 7, negative 7, and 1 8. So I'll plug that in. Negative 7 and 1 8. Good. Let's try another one like that. This time we're writing our answer as a decimal. They're already in decimal form, so I can just multiply. So I have 8.2 times 0.5. 5 times 2 is 10. The 1 goes on top. 8 times 5 is 40. Plus 1 is 41. And then I have two numbers behind the decimal. 1 here and 1 here. So that means I have to move my decimal 2 places over. And my final answer is 4.1. I can drop the 0 behind the 1 because that doesn't change the number at all. I could also write 4.10, but I can drop the 0 and just do 4.1. Okay? Notice I didn't multiply, I didn't do a second row and do 0 times 2 and 0 times 8 because anything times 0 is just going to be 0. And that's not going to change my answer at all. So I don't even have to do that part. Oh, I almost forgot something. I have to remember my sign. A negative times a positive becomes a negative. So I have to put a negative in front of that. And it's negative 4.1. Good. Okay, let's try one more. This time we have two negatives, a negative 1 and a negative 4.5. Two negatives become a positive. So I know already that my answer is going to be positive. And actually, anything times 1 is just itself. 4.5 times 1 is just 4.5. 10 times 1 is just 10. 5 times 1 is just 5. So this is kind of a nice, easy one. It's just going to be 4.5. Okay? All right. Second link that we have is the distributive property. Okay? Whenever I have a number in front of parentheses, that number needs to be multiplied by everything inside of the parentheses. So in this case, I need to do 5 times 1, and I need to do 5 times h. So 5 times 1 is 5, 5 times h is 5h, and then I still have the plus in between them. And that's really all I can do. I can't add 5 and 5h together because this one has an h and this one doesn't. They have to look the same in order to add them together. We call those like terms. They have to be like terms or have the same letter in order to combine them. So that's all that I can do. So my final answer is 5 plus 5h. That's it. All right, same thing here. The number in front needs to be multiplied by everything inside the parentheses. So I need to do 2 times 4, which is 8. I need to do 2 times 6h. I can do 2 times 6, which is 12, and then the h goes on the end. Okay? It'd be like if I had 2 baskets, each had 6 apples in them. Well, together in both baskets, I have 12 apples. So the h would represent the apples. We'd have 12 apples. Okay, again, I can't put 8 and 12h together because this has a letter and this doesn't. So that's all I can do. And I just get 8 plus 12h. All right, this is a problem where we have to factor. So we're doing the opposite of distributing, which is what we did in the first couple examples. So instead of multiplying, we're going to do the opposite of that, which is dividing. So we need to look at 15 and 5 and figure out the greatest common factor that we can divide out of both of those. So if I'm not sure, I can start listing the factors of both numbers. So 1 goes into 15 times, 2 doesn't go into 15, 3 goes into 15 5 times, 4 doesn't go into 15, so then that's all I have. 1 goes into 5 times, 2 does not go into 5, 3 does not go into 5, 4 does not go into 5 evenly, so that's all I have. So the biggest number in both of these is our greatest common factor. And I can see the biggest number is 5. So what I'm going to divide out of both of these numbers is 5, the greatest common factor. 15 divided by 5 is 3, and then I still have the z with it, plus 5 divided by 5 is 1, and then I put parentheses around that, and the number I divided by, which is 5, goes in front of the parentheses. And that's my answer. It doesn't look very nice or simple, but that's how factoring works. Now, if I did that correctly, if I distribute, I should get the original problem back. So let's try that once. If I distribute and multiply, 5 times 3 is 15. Keep the z. 5 times 1 is 5. Did I get the original problem back? Yeah, I did. So then I know I did it correctly. But all of this in green is my answer. So I have 5 parentheses 3z plus 1. Okay? Good. One more distributing. Again, we multiply. 4 times 1 is 4. 4 times 5 is 20. Don't forget the x. and all of that is our answer. So we have 4 plus 20x. Good. Third link. We are multiplying and dividing. We have -6 times a +5. According to our division rules, unlike signs becomes a negative. So we know it's going to be a negative number. 6 times 5 is 30. Our answer is simply just -30. Just applying our multiplication and division rules. Good. Here we have 42 divided by 6. Again, we have a negative and a positive. They're unlike, so it's going to become negative. Then I have to divide 42 by 6. If I'm not sure, I can take a guess and then keep adding multiples. So I think it might be somewhere around 6. Well, I know 6 times 6 is 36, but that's not enough. So I add 6 more, and that gives me 42. So that gives me the right answer. So that means 42 divided by 6 is 7, and 6 times 7 is 42. Subtract and we get 0. Again, our answer is negative. Because they're unlike, we get a -7. Okay, we'll try just one more. We have 2 divided by -2. Again, we have a positive and a negative, so our answer is going to be negative. 2 divided by 2 is just 1, so our answer is -1. Okay. Okay, some story problems, a little bit. It says a total of 300 residents left a certain town over the past 5 years. The same number of residents left each year. The mayor wants to know what the town's change in population was each year. Okay, so we have 300 people that left over 5 years. Okay, this is the total that left. We want to know how many left each year. So we would have to divide that by 5 to figure out how many people left each year. Okay, now this first one says 300 times -5. That's not going to work because that's going to give me a bigger number. It's going to be negative, but still a larger decimal. Then we have -300 times 5. Well, it's still multiplying. That's not what we want to do. We need to divide 300 into smaller pieces to figure out how many people left each year. So that means it must be none of the above. Okay, let's try another one. Grandpa Ernie is shrinking. Oh no, that's no good. Over the past 4 years, his height decreased by a total of 1.7 centimeters. It decreased by the same amount each year. He wants to know what his change in height was each year. So again, total over 4 years was 1.7 centimeters. If we want to know how much he shrunk each year, we have to divide this into 4 equal pieces, and that will tell us how much it went down each year. So I need to do 1.7 divided by 4. Okay? And since it's decreasing, this 1.7 is actually a negative number. So we're actually dividing by a negative because it's going down, which is represented by a negative number. So would it be 1.7 divided by 4, negative 1.7 divided by 4, or negative 4 divided by 1.7? Well, we want to split the total decrease in height into 4 pieces, so we have to divide negative 1.7 by 4. So it's going to be the first one. try another. A cash's cell phone bill was $79.99 per month for 3 months. His payments came out of his checking account each month. The following equation describes this situation. Okay, so we have 3 months. 1, 2, 3. Each month it was $79.99. $79.99. $79.99. So we multiply that by 3. And they put a negative number because that money is coming out of his checking account. It's a decrease in the amount of money in his checking account. So we have negative $79.99 times 3 equals negative $239.97. Says, what does negative $239.97 tell us? Does it tell us the total change in a cash's checking account as a result of these 3 cell phone bills was negative $239.97? Or is it saying that $239.97 was taken out of cash's checking account to pay for these cell phone bills? Okay? Select all that apply. So I think multiple of these make sense. Actually, both of these make sense. Okay, that's the total change in his checking account. There's a negative $239.97 because he paid all 3 of those. And $239.97 was taken out. So, depends how you write it. You can represent numbers in different ways. We have to read them carefully to understand what the sentence is meaning and what the context is. So both of those would apply. Okay. A zombie lost 3 limbs each day for 4 days. Kind of a weird problem, but that's what they have. The following equation describes the situation. 3 limbs, negative 3, 4 days. Multiply those together, get a negative 12. What does the negative 12 tell us? The zombie lost a total of 12 limbs over this time period. The zombie has negative 12 limbs. Okay, he doesn't have negative 12 limbs. He lost those. So it wouldn't be that one. And it says the zombie lost a total of 12 limbs. Yes, he lost 12 limbs. That's what the negative 12 means, that he lost them. After being exposed to an electromagnetic shrinking machine, Joe shrank a total of 120 centimeters. Okay, interesting. Over 1.5 seconds. His height decreased by the same amount each second. Joe wants to figure out how much his height changed each second. Okay, so the total height, total change is 120 centimeters over 1.5 seconds. So we want to take the total change divided by 1.5. So this first one has 1.5 divided by 120. We don't want that. We need the total change, which is actually a negative 120 because it's decreasing again, divided by 1.5 seconds. That will tell us how much he shrank each second. The total divided by the amount of time. All right. I think it's good. All right, multiplying positive and negative fractions. Again, the nice part about these is that we do not need a common denominator. We can just multiply straight across. One thing we should look for is any canceling that we can do before we multiply. For example, on this problem, I see a 5 on the bottom and a 5 on the top. I can cancel those 5s and they become 1s. Because 5 divided by 5 is 1, 5 divided by 5 is 1. Now I can multiply straight across. 2 times 1 is 2. 1 times 9 is 9. A negative and a positive, they're unlike, gives us a negative. So our answer is going to be a negative 2/9. All right, same thing again. See if we can cancel anything. I can't reduce either of these fractions, and I can't cross cancel anything or reduce, so there's nothing I can do. I just need to multiply across. 7 times 1 is 7, 2 times 6 is 12. A negative and a positive, they're unlike, makes a negative. So we just get a negative 7/12. Good. One more. Again, we can't reduce either of these fractions, and we can't cross cancel anything. So all we can do is multiply. 7 times 7 is 49. 8 times 5 is 40. Two negatives, they're like, is going to make a positive. So that turns into 49 over 40.